Hello, this is video 2 of my new channel. This video is about genetic algorithms. I'm now going to step through some slides to introduce the video. Hello, this is video 2. In this video you will see the demonstration of a genetic algorithm. GAs are based loosely upon Darwin's theory of evolution, where individuals exist in a population and compete to survive. GAs can solve very large complex problems with many variables, and they do not rely upon calculus, but only the ability to compare two solutions. The function that we're going to solve in this demonstration is a simple function. It's a cycle of a sine wave, where the value of the variable can vary between 0 and 4000, and the solution exists at 2000, and this represents 90 degrees or pi upon 2. Normally you would not have this solution beforehand. However, this approach allows us to observe the performance of the GA during its execution. We can see quite clearly the changes that are made to the error measure. This algorithm uses real variables, single point crossover, with a population of 20. It employs tournament selections, where two solutions are compared and the best is selected. Mutation uses real valued creep. The solutions are ranked, and the top two solutions are the elite solutions. A graphical display is made using a bar graph, a horizontal bar graph. Green is the actual value, blue represents the error below the solution, and red is the error above the solution. The goal is to eliminate all the blue and red bars. So when we see all green, we've solved the problem. The normalized values for the fitness are shown in the final column. The second last column shows the overall fitness of a row. You can determine if the system has converged by looking at the final column, which gives a sort of a staircase effect of green bars. Here is a list of all of the classes used within this project. Note that the GA runs within a thread. There's a graphics object to display the results incrementally as it runs. Everything is all placed within a frame where we can alter the length and the population size. I am the original author of this code, although I have used small blocks of code published by Sun to open files and create sockets, etc. I've used the MVC paradigm to build this project. This window shows a project with all the files loaded here. Source files in this position. Down here you can see the functions and variables. Here are the various output values from the GA, and here is the visual representation of the same information. In this slide, the execution of the GA is complete. We look over here and you can see the staircase that I was talking about, and virtually all of the red and blue have disappeared. Here we have the top two elite solutions. What have we got here? Well, in this case what I've done is I've altered the name of a package variable and forced an error. This is where the errors occur. What what we've got here is I've set the increment variable very high, and as a result you can still see that the system has a lot of diversity and it's got a solution, but there is still a lot of red and blue, which is undesirable. In this window we can see the design tool with the sliders, run and stop, and over here that's the frame, and what we've done here, I've run it right to execution, right to the end, and here we've got the increment value set to a very high level, and again it means that we've got a lot of diversity. Here I have loaded a project called CAND into the Netbeans environment. I can do a clean build, which will recompile the program here, and this information tells me that it has been built successfully. Any errors that could be generated will be here with a line number marked. So here we have the classes defined. In this area is the code area with the length, which represent the number of variables, the population, which is the number of rows, and the default iteration count. I'm now going to run the project. Okay. I'm altering the number of variables, reducing the iteration time, the iteration count, and setting the incremental value to 0.6%. What you can see here is that the solution has now been found. All green means that a valid solution has been found, and this staircase indicates that the system has converged. I'm now going to actually select the model and show you the function that generates the value. Down here, this set of numbers represents the solution in terms of the output values. Here we have a normalized value for the fitness, and this column here gives an indication that the system has converged. Clearly, it is very difficult to interpret exactly what's going on when you just look at a massive number of numbers like this. I will run the algorithm again with a different set of parameters. Now what I'm doing is this reduces the time for the run, but I'm going to actually set the incremental value at 9% of the full range. And you see what happens here is you get a great deal of diversity. The red and the blue is the actual best elite solution, and the red is the average solution. Clearly all of the rest of the population has not converged, and this is the reason why you see the two lines side by side. I can stop this at any time because the GA thread can be interrupted. I'm now going to run the algorithm with different settings and remove the last data output. So now a greater number of variables, a greater number of iteration counts, but a moderate amount of it. So what's this, 2%? If I just move this down for a moment, you can see these are the solutions coming through, changing with time. That represents, this value here represents about a 1% error. As I said before, I can stop this at an intermediate stage. The next thing I'm going to show you is the frame and the design window. So we have the buttons to control the process and 3 sliders. One to determine the number of variables, the iteration count, and the magnitude of the creep function. Well, that's the end. I hope you found this demonstration interesting. Bye-bye. Here is some useful information about Netbeans Ide. Here is the address where you can obtain Netbeans. I use the SE edition to compile this project. If you're interested in running it on a Raspberry Pi, you could use this edition here, the OS independent version. So here we've got, this is the page where you can download the application. This is the SE edition. This is the Enterprise edition, where you also get web servers. And up here you can select the version that will run on a Raspberry Pi or Linux. So here are some key features of Netbeans. You get a GUI that can save time during development, embedded help, colored text, effective file management. You can navigate between different functions and variables. There's a console window, and there's a very helpful prompt where you type object dot and then it prompts you for the information that can fit in that position. You can refactor your project, and there are embedded libraries.